Okay, so today we are talking about iteration, the last control structure that we need to cover this semester. Specifically, this presentation focuses on the while loop, and that's the only loop we're going to practice. Please remember that there are three control structures: sequence, selection, and iteration. Sequence is when every line of code executes one after the other, which is the first style of programming that we have learned. Selection is specifically the if statement. You have a condition, and the condition determines whether you do something or you don't do something. So we select with that condition whether to execute or not the line or lines of code that are inside the if statement. And finally, iteration means repetition, and what we have for that is called the loop. So the loops will have a syntax that is very similar to the if statement, as I was telling you in our meeting. Basically, what we're going to do is replace the keyword if with the word while. And we need to be very careful when we deal with loops not to create what is called an infinite loop, which is a loop that repeats endlessly, which causes the program to never stop. Okay, so for this video, you are going to do the practice with me, and I have numbered the examples. I believe we have 9 examples that you're going to be coding. Obviously, we start very simple and we gradually get more complex. So this is the first example. Please code it in Python and take screenshots, paste them into a Word document, under the title example 1, displaying the value of a counter. So I have a variable that I name counter, and I initialize it to 0 because I'm going to count how many times I go through the loop, and I'm going to display the value of that counter each time I go through the loop. So notice the structure of the while starts with the word while, the keyword, that's why it's orange. Then we have a condition, counter less than 5, colon, don't forget the colon, like me. And then inside the loop, I have 2 executable statements. These 2 statements will execute as long as the counter has a value lower than 5. So we're going to display the value of the counter, and then we're going to increase the value of the counter. So this this statement here, counter plus equals 1, is an abbreviation for counter equals counter plus 1. Since when we're dealing with loops, we continuously do calculations that increase the value of a variable by a certain amount, we have this abbreviated instruction. Plus equals, it allows you to eliminate repeating the name of the variable that you use to calculate the result. So since you're using counter to calculate the result of counter, then to avoid a repetition, you can just say plus equals, and in this case 1 because we increase it by 1. But the values could be different, and the calculation could be different also. It could be times equals, etc. So what is this going to do? The first time we go through this, we arrive to the condition, the value of the counter is 0, 0 is less than 5, the condition is true, so we go inside the loop, we display the value of counter, so we see 0, and then the counter gets increased to 1. We go from that, we go up to the, after this is executed, we go back to the condition, and now we arrive the condition with the value 1. So we're going to check if 1 is less than 5, and it is true, so we're going to display the value of counter here, 1, and the counter is increased by 1. So now we are going to arrive to the condition with the value 2. So it's going to check if 2 is less than 5, and it is, so it's going to go inside and it's going to display it, and it's going to increase to 3. So you get the rhythm going. So now we check if 3 is less than 5, and it is, so it displays the value of the counter, which is 3. We increase it by 1, so now the value is going to be 4. And we're going to check if 4 is less than 5, and it is, so we display the value of the counter, which is 4. And now we increase the value of the counter, and the value of the counter is going to be 5. So we're going to check if 5 is less than 5. The condition is going to be false. So it's going to go to the next executable statement outside of the loop. I don't have anything else, which is poor style. We should always have a goodbye or thank you or something like that. But this is the first exercise, so for that reason, I don't have anything there. So please code this, take the screenshots, put them in a Word document, and we're moving on to the next example. Second example. Rather than displaying the counter, normally we want to do something inside the loop. So now we're going to display your name 5 times. In this case, we put the name inside as a string literal in the output statement. So we have the counter starts at 0 while counter less than 5. So now you have in your mind, right, what the counter does. It goes through 0, 1, 2, 3, 4, 5. And when it reaches 5, the condition will be false, and we're going to go outside the loop. So incidentally, Relsan is a very famous female surfer from Marcaja. She is no longer alive. So I chose her name because it was a very sweet lady. So that's why I decided to add the picture to make it a little more colorful. So now, rather than displaying the value of the counter, each time we go through, we call it each iteration of the loop, we are displaying Relsan. So you see 1, 2, 3, 4, 5 times Relsan gets displayed, and then we're done. When we reach the end, the value of the counter is 5. So please code this with your own name rather than Relsan, and run it once because it only does one thing. If you would like to experiment a little bit, you may want to change the value of the counter and see what happens. Third example, displaying user input 5 times. So now the loop stays the same, but rather than having the name hard-coded in the program, we're going to ask the user what the user's name is. So for that reason, we need to add another variable. So we have the variable name. I added it. And just so I have a variable determined before I prompt for the value, I do this. This is like declaring the variable. I say this program is going to have the variable name, and I don't have a value in it, so it's an empty string. So then in the section for getting input, I prompt the user for his or her name. So name equals input, what is your name? And then we have the same loop basically, but the only thing that changed a little bit is this line of code, where rather than saying print Relsan, now it can be any name, right? So it greets the person aloha and whatever the name was typed in, which in this case I run it entering her first name, and then it displays aloha rel 5 times. So please code this interactive. Enter any name, maybe enter your full name rather than just your first name, or experiment with a different version of your name, and take the screenshots and put them in a Word document. So the loop is still doing the same, nothing new here, except for making it interactive. Okay, so we can ask more questions to the user. So this is the reason why it's good to have an idea of the different sections of the algorithm. So this is a program that asks the user for the user's name, their favorite flower, their favorite color for that flower, and then it's going to display a sentence using the three values that were entered by the user. But it repeats the sentence 5 times. So we have done this before to learn the interaction with the user in one of the exercises, but now it is the same thing, but it's repeating the output 5 times. So rather than coding print da 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 da, print da 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 da, print da 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 5 times, then you code the line only once. You make sure that you alter the counter, and it's going to display it as many times as you indicated in the condition. So this makes your program a lot slicker, wouldn't you say? Anytime that you find yourself repeating lines of code and you find yourself doing copy, paste, copy, paste, copy, paste, or paste, 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 it means that you probably could find a way to use a loop for that. So this is your fourth example, just adding a little bit more interaction with the user. Not a lot more complexity added here. So in this case, I asked for a flower. What is your favorite flower? And then what is your favorite color? And then the sentence is aloha, Rel, sun. Here is a white pikaki for you. You can try this with different questions if you'd like to. Okay, so up to now, we have been hard coding the number of times. And here in the condition, we had a 5. And I suggested that you could change that to 7 or to 10 to experiment with a loop. But if you change the value yourself, it's hard coded there, so it's not really very interactive. You can add a little bit of flexibility to the program by asking the user how many times they want to do something. So how many times do you want to roll a die? How many times do you want me to display your greeting? How many grades do you need to type in? Something like that. So what do we do? Well, what we need to do is, if this 5 needs to be a value entered by the user, I better have a variable where I'm going to store that value. So I'm going to have to declare a new variable in the variable section. We're going to accept the value, and then that value is going to be used in the condition. The counter is a number, and I need to compare it to a number. So don't forget, when you prompt the user for a number, it's accepted as a string, and we need to convert it to an integer. So we need to convert it to a number, and then rather than using the fixed value 5 here as your ending value, you're going to use the name of the variable. So here is the code. On the left, the original code. On the right, the code that you're going to have. So rather than continue to prompt for the 3 pieces of information, you're just going to ask for only one question. See in the output screen here, you're going to ask 2 questions. You're going to ask for a favorite word, and then you're going to ask how many times do you want to see the word. So we no longer we're not going to need the name anymore, and we're not going to need the flower, and we're not going to need the color anymore. So we're still going to need the counter, because the counter keeps track of how many times you go through. We're going to ask for a special word, so that's going to be the string that I'm going to use to repeat the output. And we need a new variable for the stopping value. I named it stop. You can call it anything similar to stop. So I prompt the user for the special word. What is your favorite word, or something like that. And then I'm going to prompt the user for the stop, but notice that we have 2 lines of code. We need to make the stop an integer. So then when I use it here in the condition works. If I don't make it, anytime that you're running a program and it tells you, you type in a number that should make the condition true, and you see that it doesn't, it gives you the opposite, that the condition is false. Check the data type of your value, because if you compare an integer to a string, they're never going to be equal to each other. Okay, so so then the condition and what happens inside is almost the same as before. So the condition reads, while counter is less than stop, display the word and counter plus plus. So only 2 lines of code inside the loop. And because I have typed in that I wanted to see supercalifragilisticexpialidocious 10 times, then it repeats the output 10 times. And at the end of this execution, the value of stop is 10, and the value of the counter is 10 also, because 10 is not less than 10, and that's when it stops. Please code this new program here and run it. Maybe run it with a couple of values. So enter 1 and then enter a number different from 1. Enter a negative number and see what happens. Okay, next example. What if I want to limit the number of times to a number between 1 and 10? So when we ask the guy, how many times do you want me to repeat the word, the output, whatever, we don't want the guy to tell us 100 times. So we want the guy to type in, or the user to type in, a number between 1 and 6. So the condition needs to be written like when we want to find out if a value is outside the range. So remember, using or and less than the starting value or greater than the ending value. So that will check for a value outside the range. So less than 1 or greater than 10. So notice here in the blue box what I have. The syntax is going to be while stop, which is the stopping value that the user types in, is less than 1, or stop is greater than 10. So that means that when I prompt the user for the value, I want to make sure that the value is between 1 and 10. If the value is outside of that range, it's going to continue to ask the person for the value. So notice the code. I still have in the variable declarations the same 3 variable declarations that I had before. I have a counter, a special word, and a stopping value. So you can continue to code from the same file in Python. Then what changes is that we prompt the user for the word, we accept it, we don't need to change anything there. But then when we ask the user for the number of times, we ask them to enter a value 1 to 10, right? So we want the person to type in a value 1 to 10. So for that reason, we incorporate this additional loop that we didn't have before. We put it in the input section because we're asking for input. So while stop is less than or equal to 0, I could have just said less than 1, or score or stop Well, stop is less than or equal to 0, or stop is greater than 10, then prompt the user and convert the value to an integer. We need to convert it because we use it here in the condition. So it's the same two lines of code. I just incorporate them below a condition with a while. So what is this going to do? Well, notice the output. While the value is outside the range, here, these three values are outside the range, then it repeated the question. Okay, so that's what it does. So I enter 20, 0, 15. Those are all invalid inputs. So it prompts again, prompts again, prompts again. And then when I type in at 8, then it repeats the word 8 times. So please code this. This is a program that has two loops, one for the input and one for the output. So that loop that we have just added is a loop that validates input. So what is an input validation loop? A loop that continues to repeat while the input is wrong. And that's why I insisted when we were doing the if statements to remember how to find out, how to check if a value is within a range and how to check if a value is outside the range. So in this case, the condition was trying to find out if the value was outside the range. So we were checking if the value was less than the starting value or the value is greater than the ending value. The ending value of the range. So let's write a program that validates the value of a course score to be between 0 and 100. So we're going to write a program that prompts the user for a grade, in a numeric grade, and we're going to convert it to a letter grade. So this is your 7th exercise. You're going to code it and follow the same routine as usual. Okay, so this program is, the logic is a little different already from the get-go, but we're still doing something similar. So we, the variables that we have are the score, the numeric grade that the person is going to type in, and we're going to convert it into a letter grade. So it's going to be a string. And we don't need any more variables, okay? So to get the value, we're going to prompt the user for the grade. If I want to make a distinction between, if I want to have a specific output statement that tells the person, you made a mistake, try again, or something like that, then I need to make the first input outside of the while loop, and that would allow me to differentiate between the first input and then the one that is necessary because the person made a mistake. So if I want to have an error message, this is one way to approach it. Another way to approach it would be to have an if statement inside with a counter, so if it is not the first time, then we have the error message. So I like this style, and it's very common to have the first prompt different from the repetition for the mistake. So I have a prompt, and don't forget to convert it to an integer. Then you have the condition. It's kind of like saying if, right? If the score is less than 0 or the score is greater than 100, colon. We used to do this with an if, and then we would say, sorry, it was a mistake. Now, rather than saying, sorry, it was a mistake, we say, hey, you made a mistake, please try again. So, so notice that my prompt can be different. Your score should be between 0 and 100, try again. And so the person will type it in, it will be stored in score, and we need to convert it to an integer. Don't forget to do this, because from here, it will go back to the condition. From here, it will go back to the condition with a new value. So this value better be an integer, so it can be compared to the 0 and compared to the 100. So it will get stuck here while the value is incorrect. Once that is correct, then we're going to convert it to the appropriate letter grade. So the standard categories are if the score is greater than or equal to 90, it's an A, else if the score is between 80 and 90, so greater than or equal to 80 and score. Be careful here, it has to be less than 90 because the 90 is the equality with the 90 is for the A. So here we need to make sure that we don't include the 90 for the B, right? So greater than or equal to 80 and less than 90, then it's a B. Same likewise for the C, greater than or equal to 70 and score is less than 80, it's a C. Else if greater than 60 and less than 70, then that means that it's a D. And if it's not an A or a B or a C or a D, it has to be an F. So this long if, else if, what it does is to convert the score that the person typed in into the corresponding letter grade. Obviously, this program could be a lot longer and it could have calculations. The whole algorithm for our calculation of grade could be done instead of having the person typing in the score. But that would be too long of a program. And what we want to do is practice the loops with short exercises. So you see different examples. All right, so this converts into the corresponding letter grade, so then I can display. So this is a program that doesn't have any calculations, so it doesn't have any processing section. It gets the values. It's not only getting input, it gets the input and then it converts the input into the corresponding letter grade. So I incorporated this area into getting values. Some of you could consider this part of a process. It could be considered process. It's one of those things that could be one or the other. And then we display the output. So if we look at the first example here, what did you score in the class? 110. That is unacceptable for this program, so we continue to prompt. Your score should be between 0 and 100. Try again. So the person types in 110, 101, negative 100, 105, 11. So when 11 is typed in, then it should be an F. So here you have to run this with examples that are immediately in the range, then an error, and then a couple of errors, and then you need to enter, check that each one of the parts of the if statement works. So enter a grade that is for an A, a B, a C, a D. Notice that I did that, right? So I have a 96. I went in order so I don't get confused, and it shows me an A, 88, and it shows me a B, and so on. You see that I tested that the if statement works correctly for all the different values. Okay, so please try this, code this. Don't forget to convert the input into an integer so the conditions work. All right, so until now, all the loops that we have done, the first one was with a counter. So when we have a counter that needs to reach a value, we call that a counter controlled loop. We had an input validation loop. We used it twice. The first time that we saw it was in a short example when the guy needed to type in how many times they wanted to repeat something. So for the validation of the number of times that we should go through the loop, meaning the input of the stopping value, we used a loop for that. And then we validated the input of a numeric score for a course. Now we're going to deal with this that is called a sentinel value. Sentinel value, you can think of it as a goal. So if you are accepting donations, like in a GoFundMe, you're going to continue to ask, oh, we haven't reached it, we haven't reached the goal, we haven't reached the goal. Or let's say that you're pitching in for a gift. So you ask your friends for donations for the gift. Then each person donates a value, so you add it, you add it, you add it, but you know that you want to buy a $500 gift. So you need to continue to add until you reach 500. So 500, which is your goal, is your sentinel value. So you're going to continue to add to your little donation box until you reach 500, right? So that is what we call a sentinel value. An example of a sentinel value is you may know the game of craps. There is one of the goals is not to roll a 7, so the same person rolls until the person rolls a 7. So the person has 2 dice in the hand and they blow on the hand and they roll it, everybody cheers, and hopefully the person didn't roll a 7. So here we're pretending we're not doing the whole game of craps, but we're just doing that. We're just rolling 2 dice and we're adding the value of the 2 dice until we hit a 7. So for that, so notice the output. So we have here, in the first roll I have a 7, have a nice day. So now I remember to put some kind of output statement outside of the loop. The second time that I roll my dice, that I run the program, I got a 9, a 5, a 9, a 12, a 11, a 3, and a 7. Then have a nice day. So it can take it can be right away, or it can take a whole bunch of times. So how do we do that? We're dealing with random numbers, so don't forget we need to import the random library. So that goes above the variable declarations. So we're going to have a roll that is going to be the addition of 2 dice. So then I have a variable for the first die and a variable for the second die. So now, rather than having one random value for the player and one random value for the user, we have 2 random values for the player. So this is what we're going to do. So we need to, the actions that we need to do is we need to roll the first die, so die 1, random.randint 1 to 6, die 2, roll the second die, random.randint 1 to 6. So nothing new in terms of the concept, just the fact that we rolled 2 dice, and then we add them together. So if it is a 2 and a 5, it's going to be a 7, right? So die 1 plus die 2 is the value of the roll. And then I display the value of the roll. So I'm not displaying the 2 dice separately. I display the addition of the 2, the value of the roll. Now this needs to happen until we hit a 7. So while the value is not a 7, so while roll does not equal 7, do this. So this is going to be repeated, and repeated. So this is my loop, right? So these 4 actions, they get repeated continuously until we hit a 7. Eventually, we always hit a 7. It can be right away, like in the first example, or it could take an n number of times, but eventually we are going to hit a 7. And then we say, have a nice day. So please code this. This is the starting point. You don't need to take screenshots because we're going to continue from this. But please code it and see that it works. Okay, so we can make 2 improvements to this code. The first improvement that we're going to do is we can count how many times it takes the player to roll a 7. Because when I showed you my 2 sample screens, I had one in the first shot I got a 7, and in the next time it was 5 or 6 times it took me to get a 7. So we may want to count how many times it takes to get to a 7, because later on we're going to see how we can use that counter to calculate something else. So how would we count how many times? So I call it ticker. You can call it time. You can call it times, you can call it count, whatever you want to call it. I imagine the ticker when you go, now that they count how many people go to a store, the person in the front has a counter in their hand. They call that a ticker. So that's why I call it a ticker. But you can name it anything similar to that. So the ticker is not going to have anything to do with the stopping condition, right? The ticker is just to count how many times we go through the loop. So we start at 0, and then inside each time we go through the loop, we're going to add 1 to it. So everything else stays the same inside the loop. So the loop will happen while the roll is not equal to 7. And we're going to roll the 2 dice, add them together, and display the value. But the only difference is we're adding 1 to the ticker. So ticker plus equals 1, which is the same as saying ticker equals ticker plus 1. So we're going to be stuck in that loop. Once we reach the ticker plus 1 line, we're going to go back there, and it's going to compare if the value of the roll is different from 7. So if you go through it only once, the ticker will be equal to 1. If you go 3 times, the ticker is going to be 3. So the first 2 will be a different value than 7, and the third one will be the 7. So here you have my examples. And then, of course, if you got the ticker, you want to display the ticker. It took you this many times to roll a 7. So here I got a 6, a 9, and a 7. So on the fourth one, it gave me a 7. So you roll 4 times to roll a 7. This is what we're adding. My next example, I got a 5 and a 7. So I rolled twice, and it means that I won only once. This is going to be important, that the number of times that you win is 1 short of the times that you roll, right? Because the last roll is when you stop, is your loss. So add this line of code, add the ticker, add the increase of the ticker, and run it and see how that works. Once you're done with that, come back and we're going to talk about the next example. Okay, so what we want to do is we want to add a bank for the player. Remember that we had this concept before. If you win, you get +2. If you lose, you subtract 2. Okay. So in this case, for each time that the person does not roll a 7, we add 2 to the bank. So we need to add a variable for the bank and start it with a value. It cannot start at 0 unless you're going to prompt the user for how much you have on your bank. So we're going to start with 20, and we're going to say that the bet is 2. Okay, 20 chips, 2 chips, or $20, $2, whatever you want it to be. Then the loop is still the same. We're going to continue to loop, loopy loop, loopy loop, loopy loop, and have the ticker. So we're not changing this. We're not changing the loop. What we want to do is increase the value of the bank by 2 per time the person won. So the person won the number of times that it went through the loop minus 1, and we multiply that by the bet, right? And we add that to the bank. So if the person went through the loop only once and got a 7, then the bank is going to stay intact because 1 minus 1 is 0, 0 times 2 is 0, and we add 0 to the bank. But if the person roll a 5 and then a 7, like in my example, then 2 minus 1 is going to be 1, and then multiply by the bet, 2. 1 times 2 is 2, and we add 2 to the bank, so it's going to be 22. So let's see what happened. When I run it, I got a 7 on the first time. You roll 1 times, so this means that we could add an if statement to improve this. So you roll 1 times to roll a 7, your bank equals 20. See? And then I roll a 6, a 3, and a 7. I roll 3 times, and it added $4. It didn't add 6, so it added, 3 times the roll. So 2 are the winning ones, so that's why it will do ticker minus 1. So 3 minus 1 is 2. 2 times 2 is 4. 4 added to the bank. Chi-ching, 24. Okay, so this is the last improvement to this program. So when you finish coding this, take the screenshots, add them with your title to your Practice With Me Word document. And this is the last example for today. So what if the sentinel could be the result of a calculation? So what we're going to do is kind of like a program flashcard for the modulus calculation. That is the one that gives us the hardest time. So at the same time that we write the program, you're also going to be practicing the calculation itself. So let's say you would like to write a program that helps the user practice the modulus calculation. The program asks the question, the user types the answer. The program continues to ask for the correct answer while the user answers incorrectly. So here's your encouragement to learn. Note, to be able to practice multiple times, the numbers used in the calculation are random numbers 1 to 10. So we're not going to have the values hard-coded. You're going to randomize it. So any number 1 to 10, modulus any number 1 to 10, you're going to ask the question to the user, what is the result of this calculation? So the person types in the value. If what the person types in is different from the result of the calculation, then it will continue to ask. Let's see how to code that. Okay, so this is a program that will have the first and the second value of the calculation, so I just named them first and second, and then the program needs to calculate ahead of time the correct answer. That's going to be the sentinel value. And the user will answer, right? So I have the variable for the correct answer, that's the calculated result that the computer will calculate, and the answer that the person will type in. And then first and second are the two randomly generated values. So I need to get those random values 1 to 10 for the mathematical calculations. So first is a random value 1 to 10. Second is a random value 1 to 10. And we display the question. So what is the result of first modulus second? We ask the question. And the person types it in and it's accepted. So I ask in 2 lines. That way I can be more user-friendly on the first statement. And then here I ask them to please enter the value. Type your answer. So we accept it, we store it into answer, and I'm going to definitely use this to compare in a condition. So I need to convert it to an integer right away so I don't forget later. So those are the values that I need to get. This program has a process because the program needs to calculate the correct result. So correct equals first modulus second. So now you have the value that the guy types in the variable name answer, and you have the correct value in the variable name correct. So you want to find out if the guy answered wrong. So if the answer is different from correct, we need to tell them, sorry, that's incorrect. So here's the loop, right? Here's the loop. So we're going to ask, we're going to say, sorry, your answer, and we repeat the value, is incorrect. Please try again. We accepted an answer, and answer needs to be converted to an integer. So we're going to be stuck here while the person answers incorrectly. When the person answers correctly, the loop is over and we can congratulate them. So we know that we don't get here until the person types in the correct answer. So once that we exit the loop, we can congratulate the user, and normally it will be a good idea to repeat the calculation. And what I did here is the shortcut, just in case anybody forgets. So if the first value is less than the second value, you know that the result is equal to the first value. So I added that as a reminder in the flashcards. So here we go. And we're going to display this only when first is less than second. So what is the result of 9 modulus 4? So my first random value is 9, the second random value is 4. And I type the answer 1, which is correct. Good job, right away, your answer is correct. And it repeats, 9 modulus 4 equals 1. Okay, and this 1 comes from correct rather than from the user input. It is important that you do this, so when you're running it, if you know that you have typed in something different, you would see this would scream at you, right? Next, I run a different example where I got a lower number, 2 modulus 10, and I did the incorrect answer many times. So I entered 10, and it says 10 is incorrect. I type in 20, 20 is incorrect. I type in 2, good job, your answer is correct. 2 modulus 10 is 2. And then the reminder, because the first value is less than the second value, I get to see the reminder. When the first value is smaller than the second value, the result of modulus equals the first value, something that we learned a long time ago. So please code that, take the screenshots, paste them in your Word document, and that's it. That's your last exercise for the last practice with me assignment of the summer session. Thank you.